Hi, Prof. Today I want to talk about decoding science for the community, making it accessible. So, to set the scene, science is a really powerful tool, but it only works when it's understood. And in our remediation project, we didn't just want to improve on the water quality, but we want to bridge the gap between scientific solutions and real community impact. But the challenge was to make technical concepts like aeration and water pollution accessible to a community that speaks a completely different language and has really different lived experiences. Was hard for us to convey that this query that was once a vital part of their lives, but over time through the human activities that happened around the query that polluted it. So our goal wasn't just to introduce aeration as a solution, but to make sure that the community understood how and why the query got polluted so that they can be part of the change and they can understand how they can improve, ensuring that our solution is sustainable. So one of our biggest challenge was storytelling. How do we communicate not just science, but the journey of the query itself? So our poster can be broken down into three sections: history, science, and future plans. On history, we trace the community's relationship with the query, what it once was, how it changed, and the impact the pollution had on their water source. And to make it relevant to their lived experiences, what we did was that we collated old pictures of the query from the residents themselves through the ethnographic research. And during our ethnographic interviews, we pieced together this history, allowing us to properly explain it using the poster. Next, onto the science section, we broke down the concept and the theory of aeration, how increasing oxygen levels can help to restore the water quality. And next, we talk about how our water remediation system applied this theory. Now, to make it more accessible, firstly, we tried to use as many simple terms as possible. Every single scientific term that we mentioned were explained with a proper definition. Moreover, we wanted to use as many diagrams as possible. This is to help them with visualization. Especially when it comes to the scientific section, we included a diagram for the depth of the water so that they can visualize what we initially thought the depth of the water is versus what it actually is. We also drew a diagram, a schematic diagram of the remediator itself so that they understand what's happening inside the box. Moving on to future plans, we also introduced an interactive QR code, allowing residents to scan and share their observations, concerns, as well as ideas for improving the water conditions. And to make sure that this is all accessible to them, we wrote all of this in Thai, and we also printed out this poster and hammered it next to the query so that anyone who walks by, they're able to see the poster and add on to it. However, one of the limitations I realized, especially regarding making it an interactive segment, we realized that no one actually scanned the QR code that we put in there. So I think another plan that perhaps the future groups can think of is to how to make these digital solutions less digital so that we are able to get their responses there and then. Because I realize that these digital solutions might work in Singapore, but perhaps it's more rare for it to work in Chiang Mai. Now, overall, this experience reshaped how I view science. That's not just about having the prerequisite knowledge, but it's rather about communication and connection. How do we break down these concepts and make it accessible to the people? Thank you.